Right, open Circuit Wizard, and to start off with I'd always put in my power supply. Now microcontrollers always use between 3 and 6 volts, so always set this to 6 volts. Next I'm going to put in my microcontroller, which is in the microcontroller bit, my GENIE. Now you get two views. You get this type of view where you've got your positive at the top, your 0 volts at the bottom, your inputs on the left and your outputs on the right, or you have this, which is called dual inline, which is a more technical view of it, which just has the pin labels. Now you've got your plus and your minus there, but your inputs and your outputs are all mixed in. I always use this view because it's easier. So drag out your microcontroller. It's important to do that because in the flowchart your outputs knows which pin 0, 2 and 4 the outputs are linked to. So if I cancel that and go back in their circuit diagram, I can see that it's 0, 2 and 4 are my output pins. Okay, so I've got that in there, right, my basic GENIE CO8. There is a C14 and a C20 and an E18. They get, and even an E28 down there. Now they get bigger and have varied inputs and outputs for more complicated things. This is a basic chip for basic things. It's got 3 outputs. They can be an LED, it can be a buzzer, it can be a piezo, right? It can be just basic things. It's got 2 inputs, a digital one and an analog one. That's what the A stands for there. So it can use like a thermistor, or it can use an LDR, something that's got an analog input, right? Something that detects rather than a switch and on or off. So I've got that in there. What I need to do now is start linking things up. Now I'm going to need my switch, right? Whether that's a thermistor or a push to make switch. I'm going to use my digital input, so it's going to be a push to make, and that's going to go in here. You can turn it around, rotate it, so it's in there. I'm going to link those two up. I'm going to link that up to my positive rail. I'm going to link my negative rail down here, and back up to there. Now I need to put a resistor in somewhere about here, and it needs to be a 1K resistor. Fairly simple so far. We've just got a lookup switch, right, and we've got a resistor to protect the switch and our GENIE. Now I'm going to link up the input, right, I'm going to link up the switch to the input pin. So the switch is now linked to pin G3, that's its input pin. Now time for my outputs. So I'm going to go with just 3 LEDs, just very simple, 3 LEDs, 1, 2, 3. And I'm going to link them up to my output pins. One there, one there, and one there. Now you don't have to do this, but I always think it's good practice to put a resistor just underneath my GENIE. Just protect it a little bit. If you've left enough room, that should all line up so it's nice and neat. Always keep your circuit diagrams neat, because then it's easy to see and understand when things are going wrong. Then I just join them up across the bottom there and press play. Right, takes me to my flowchart. It's telling me that because I haven't written a flowchart, it's not going to let the circuit work, which is a really important thing actually. So I've got my 3 outputs on G4, G2 and G0. So now getting into programming the flowchart. Firstly, my switch is linked up to G3. A switch is a digital input. If I double click on that, I can select G3 as green. So that's going to ask me a question, is G3 on? If it is on, yes, it's going to come down here. What is going to happen? Well, I'm going to want my output pin G4 to come on, and I want to wait and keep it on for 2 seconds. Then I want the other outputs to come on and join them. So one's coming on, then another's coming on, then a third one's coming on, and again I want that to wait for 2 seconds. Now you can multi-select, so you can select 2 things at once, and copy them and link them up. And I need to change the value of that high to high 0, pin 0. So I've got a 0, a 2 and a 4 all on, and they're all waiting for 2 seconds, for 2 seconds, for 2 seconds. Right? So pin 0, 2 and 4 are going to come in the order 4, 2, 0, and they're going to wait for 2 seconds. What happens then? Well, after that's happened, I want them all to go off. So I'm going to just select the outputs, and then make sure they're all turned to red, which is off. After that, I'm going to loop back round. So this is a continuous program, and my switch is going to look again to see if it works. Now I can test this in here to see if it works, and I can view the digital inputs on a panel there, so I can physically click 3, and when that happens, that comes on and waits, 1, 2, then that one on, 1, 2, then that one on, 1, 2, and they should all go off, and back up to the start to look. Alright, you see what I mean. Now I can also test it in Circuit Wizard, in the circuit diagram view, and actually physically see it happening. Right? Now I don't know that anything's happening here. So if I click my switch, now I can see the panel here, them all coming on. Now this is a basic circuit that is continuously on. There's no on and off switch, no indicator to tell me that the circuit's on. As soon as the batteries are plugged in, it stays on until my lookup switch is pressed. Now I want to alter that. I want to put in an incidental switch. Right, just an on and off switch. I'm going to pop it in right there. So I'm going to delete that, and it's going to go in just there. I want an indicator to tell me if it's switched on or not. So I want an ordinary LED. I'm going to link it up to here. Now, as with the resistor, I'm going to pop a 1K on the bottom there just to protect it. Now what should happen when I play that is nothing right now, even if I press that switch. It's not that the program's not working, because that isn't closed. Now when that's closed, that should light up as my indicator. So my on and off switch has gone on, and I've got an indicator there telling me. So now when I press that, it runs through my program, resets and goes back to the beginning, and if I want to switch it off, there we go. Got my on and my off switch. That's a very basic GENIE CO8 program. Now play around with the different types of outputs here. Play around with an analog input. Maybe think about putting a reset switch on it. Where would you put that? Alright, but that is your very basic type of GENIE microcontroller circuit. Obviously for your coursework you're going to need 2 different types of outputs, so you can't put 3 LEDs in. Alright, you might even want to try putting a bigger chip in, a different type of chip, and linking it up to maybe a 7-segment display. You might want to put the C14 in there. You might even want the GENIE C20, and you might want to try linking it up to a 7-segment display, or a decade counter, or something like that. Don't forget, you can still use the useful circuits page, and you can take bits, so you can have this being driven off a microcontroller, for instance. So you could take that bit of the circuit, and this bit, and that bit, and link them all up. Right. Don't forget you can take a decade counter as well. Again, you'd need that. Take your decade counter driver, it's got the serial number there. So try playing around with the circuits, try mashing them together. If you're going to use a comparator, don't forget you need your variable resistors in there, your light emitter diodes, and your variable resistors. Okay?